Welcome back. This is problem number 7 to graph the polynomial function x to the 4th minus 4x squared. There are different things that we can do with it. If I want to put it in factored form so that it's easier to graph, you could change this to x squared because that's the common factor, and then write this as x squared minus 4. That would give me a 0 x-intercept at 0 with the multiplicity of 2. This one would give me 0's x squared equals 4. So x is equal to positive and negative 2. Both of those having a multiplicity of 1. I know that this is a positive even function, which means that both ends point up. I have a multiplicity of 0 that bounces because that was the x squared. So I'll put a little b for bounce. I also have a 0 at positive 2 and 1 at negative 2. Both will go straight through because they had that multiplicity of 1. To graph it, I know that it needs to start in the second quadrant, do some stuff in the middle, and end up in the first quadrant. Well, what does it do? It goes straight through that negative 2. It bounces at the 0 and goes straight back up, so your graph would look something like that. Problem number 8 was just at some blank space for you to show your work if you needed to. 9, 10, and 11 are all still chapter 3. You're looking at graphing. It says, touches the x-axis at 0 and crosses the x-axis at 3, and it lies above the x-axis between 0 and 3. Touches it, that means it has a multiplicity of 2, so I know I have an x squared. Crosses the x-axis at 3, I know that that is x minus 3, and it lies above the x-axis between 0 and 3. So let's see what that would look like. That's the multiplicity of 2 where it touches the x-axis. Here's the multiplicity of 1 for the 0 at 3. It's above the x-axis between 0 and 3, which means it's in this little area. So how do I make that do that? Would it be a positive or a negative in order to go up through this one and back down through that one? That doesn't match the bouncing at 0, so I know that that one's not correct. I can go back and remove that and try something different. I need to make it bounce at 0 and then be above for this one. The only way it's going to be above is if it's here. So it bounces and then goes straight. That means that this must be a negative value. So the answer is either B or it's D. You distribute to find out that the correct answer for number 9 should be D. Number 10 says find all the zeros. I have a 0 at negative 3, a multiplicity of 1, so I know it's not B or C. I have a 0 at positive 6 with a multiplicity of 3. Positive 6, that's this one and this one, and so it's still A and D, multiplicity of 3. I'm still with this. I need to know if that multiplicity of 3 makes it cross or touch and turn around. The multiplicity of 3 wiggles through, that's a cross. The best answer is D for number 10. Number 11, we're back to that leading coefficient test to determine end behavior. It's just in the wrong order. Put it in the right order so that you can read it. Then you can see that this is a negative odd function, which is up on the left and down on the right. So rises on the left and falls on the right. Now we're to synthetic division. Remember, when we divide by the 0 and not by the 5. So this would be minus 5 because that's a factor. The coefficients are 1, 14, and 45. bring down your 1, multiply that's negative 5 and you get 9, multiply that's negative 45 and you get a remainder of 0. Using your depressed polynomial idea, and if this started out x squared, then this is going to be x plus 9 with a remainder of 0. The best answer is A. And this means that x plus 5 is a factor. Also means that negative 5 is a 0, or x-intercept, or root. Another division problem set up very similarly to this one. Our divisor is x plus 4. This will be a factor if it goes in there evenly with no remainder. Synthetic division, you divide by the 0. Coefficients negative 2, negative 11, negative 6, positive 24. You bring down your negative 2 and work on the problem. Negative 4 times negative 2 is positive 8. It gives me negative 3. Negative 4 times negative 3 is positive 12. That gives me positive 6. Negative 4 times positive 6 is negative 24. That gives me a remainder of 0. To get your coefficients, you are again using that depressed polynomial. If this was an x cubed, then this is going to be x squared and an x and then no x at all. Negative 2x squared minus 3x plus 6. The best answer for 14 is C. Problem number 15 has us taking and writing these as the same power. You could multiply 4 numerous times to find out which one of those things are, or you could change them to powers of 6. It really doesn't matter. The best answer is, for 15, 4 to what power is 256? The best answer is 4. 4 to the 4th is 256. This one you're using your calculator, you're using the E button and raising it to the 1.1 power. On number 16, E to the 1.1 power with your calculator should come out to be D. 17, this is a substitution problem. You are substituting the amount of time into the formula. Use your calculator and you type in your calculator 131. Use your E key. Use parentheses 0.047 and then another parentheses for t, and the time was 5 years. When you type all of that around, we're going to round it to the nearest whole number. Problem number 17, it should work out to be about 166, so D. All of these are for you to solve the logarithmic equation using exponential. For number 18, it would be 3 to the 5th equals x, using that under the log and then back over the log. Use your calculator to do 3 to the 5th power. And you'll find out that it's 243. Problem number 19 would be 2 to the 5th power equals x. So 2 to the 5th power is 32. The answer is C for number 19. And then you continue, write it in its exponential form. Again, that's under and over. So 4 cubed equals 64. That's B. (21), they don't ask us to solve it. We just write it again, doing that under and over pattern. 4 cubed equals x. If they ask us to solve it, we would know it was 64. So on 21, the best answer is B. On 22, 3 to the x power equals 243. They don't ask us to solve it, so we're done. The best answer for number 22 would be A. Write the equation in its logarithmic form. This says 6 squared equals 36. The base is 6. The exponent is what it equals to because you're going under and then back over, and 36. So log base 6 of 36 equals 2. The best answer for number 23 is B. 24 log base 5 equals 3 of x, so it's under and over 24. The best answer should be C. Problem number 25, the base is 10. Log base 10, the exponent is x of 1,000. 23 says evaluate without a calculator. You just use inverse operations where exponential. So this would be 3 to what power equals 81? X would be 4. Or you could use that change of base formula, log of 81 divided by the log of 3. Either way, you get the answer of 4. You can use the change of base formula, or you could know that 4 to the third power is 64, so this must be 1/3. If you're not sure about number 27, then use that change of base formula, and it would look like this. Log of 4 divided by the log of 64 equals 1/3. And then 28 is the same way. Log of 1/16 divided by the log of 4. And for number 28, you should get C, -2. This looks like an extra page to me. We've just done that one. On number 30, use the property of logarithms. This says to expand. This is a multiplication or a product. To expand it, it will become a sum. The only one that's added is D, so number 30 has to be D. This is also a multiplication problem, so it has to be added. It can't be A and it can't be D. Those are not a sum. Which one is it? It's log base 5 of 25 plus log base 5 of x. Log base 5 of 25 can reduce to be 2. That one's simplified. And then problem number 32. This is a quotient. To expand it, it becomes a difference. It would be log base 3 of 7 minus log base 3 of 5. 33. They ask us to expand it. This is a power. To expand it, the power goes in front, and that's the only difference. So we move the power into the front place. 5 times the log base n of x. So the answer is D for number 33. 34, this is a quotient. To expand it, it becomes a subtraction. So the answer cannot be C, and the answer cannot be D. Which one is it? This is log base W of 13x minus log base W of 2. This could be rewritten because this is a product. So log base W of 13 plus log base W of x minus log base W of 2. The best answer for number 34 is B. They expanded this. And then the last one says use common or natural. Evaluate it using your calculator. This is a change of base. It would be log base 8 divided by the log of 5. And your answer should be on number 35 about 1.2920. So the best answer is C. Thank you very much. I'll post this and you can let me know what you think.